As always, the first thing you want to do is carefully read the lab procedure, which I know may be torture for some of you, but it will end up paying off because you'll be able to answer the questions in the lab and get all the points. So I want to pay particular attention to the information in the chemical concepts because this lab, way more than other labs, requires that you come back to get information in this chemical concept section. So first I want to bring your attention to table 10.1, evidence of chemical change. Many times when a chemical reaction occurs, particularly inside our body, there's not always evidence. However, the experiments that you're going to observe for this lab have all been chosen so that they do clearly show evidence of a chemical reaction or chemical change. So this is what we're looking for: bubbles, formation of a solid, and we haven't seen formation of a precipitate yet. But when a precipitate forms, it looks milky. So if you see something that looks milky, and in the balanced chemical equation a solid is one of the products, then that's the formation of a solid. Change in color, heat is produced or absorbed, and you won't be able to feel a test tube, but you can see if a flame happens, and you can just write a flame forms, and that is always an indication of a chemical reaction. Okay, so chemical equations, you will have to balance chemical equations in this lab. We're familiar with all of these different symbols. You may not be familiar with this delta, which is used to indicate heat. And we remember when we balance a chemical equation, we change the coefficient only. We count the number of atoms of each element on each side of the arrow by multiplying the coefficient by the subscript, and then we change the coefficient so that the same number of atoms of each element are on both sides of the arrow. Alright, now another important table that you're going to refer back to is table 10.3, and this has common types of chemical reactions, which is a little different than the classification system in our textbook. So combination occurs when you have two reactants to form one product. Decomposition is when you have one reactant that forms two or more products. Single replacement, so this is a special type of redox. We know anytime an element reacts, it's redox, but this is a very special type of redox where you always react an element, typically a metal, with a cation, and that cation can either be the H plus from an acid or a metal cation like iron plus 2 or copper plus 2. And then on the other side you get a different element, and the metal becomes a cation, or the element becomes a cation. If the element was hydrogen, it becomes a cation. So the chloride, the anion, just hangs around for the ride and helps balance out the charge of whatever cation there is. So on the left here our cation is H plus, and on the right our cation is magnesium plus 2. Double replacement is what they're going to call the switching of ions, which for us was strong acid and strong bases, which we won't see in this experiment, and also the formation of precipitates. So here's an example of a precipitation reaction by switching the cations and the anions. And then combustion of a hydrocarbon is when we react oxygen to a hydrocarbon to form carbon dioxide and water. So the way that this lab is going to work, instead of actually performing this experiment, you're going to observe somebody else performing this experiment. There's a list of videos, one per each reaction except for the reaction of hydrochloric acid with sodium carbonate. For that experiment you were supposed to take a splint and light it on fire and then place it into the test tube where you reacted sodium carbonate with HCl. So you're going to watch two different videos, one of the reaction of HCl and sodium carbonate, and one of the reaction or what happens when carbon dioxide is put on top of a flame where a flame is in carbon dioxide. So here are the pre-lab study questions. Very important to balance both 4 and 5. Many times people forget to balance 5. Let's just go over how to predict the products for part 5. So we're going to add potassium and nitrogen. Whenever we react a metal with a nonmetal, we get an ionic compound. So you'll figure out the formula because potassium always has the same charge, +1, and nitrogen as an anion always has the same charge, -3. Once you figure out the formula of the product, you just balance it. B, combustion of a hydrocarbon, you know how to do that. The products are carbon dioxide and water. You can balance that. C is single replacement. So aluminum becomes an ion and will have a +3 charge and will form a compound with sulfate. So sulfate has -2, so you've got to figure out how to write that chemical formula correctly, and then copper becomes a solid. So once you write down the products, go ahead and balance the chemical equation. Cobalt-3 chloride and silver nitrate, this is a precipitation reaction, double replacement, so we're going to switch our ions. Just be sure to remember that cobalt has a +3 charge and retains that +3 charge. And then the decomposition of magnesium carbonate will form magnesium oxide. So it's an ionic compound. Magnesium has +2 charge, oxide has -2, and carbon dioxide. So as you fill out your lab sheet, you want to make sure you fill out everything. In the video, you'll see what magnesium looks like. Write down what it looks like. Is it shiny? What is its color? And then the evidence of a chemical reaction. Balance the chemical equation and then identify the type of reaction based on the table 10.3. Okay, so one thing I want to point out here is for the reaction of sodium carbonate and HCl, the type of reaction is not obvious. It is actually a double replacement. It is not combustion. They're not asking you about the burning match. They're asking you about this, and it is double replacement. All right, if you have any questions, please just send me an email. I'm happy to answer any questions you have about this. And the last page, most of this is just balancing and classifying. The one thing I want to go over is Q5 because you've got to predict the product as well as balance it. So single displacement, remember that's a special type of redox where the element becomes a cation. So zinc always has a +2 charge and it will form an ionic compound with the bromide. And then copper, which is the cation on the reactant side, will become an element on the product side. So just Cu, solid. This is a combination reaction, so two reactants will form one product, and this is actually HCl. H has a positive charge, Cl has a negative charge. So balance that chemical equation, and then as we saw in the pre-lab questions, the decomposition of magnesium carbonate is the products are magnesium oxide. Magnesium has a +2 charge, oxide has a -2 charge, and carbon dioxide. And then this is a double displacement, which is another way of saying it's a precipitation reaction. So you switch the ions, identify what the solid or precipitate is. So this is one of the more demanding labs in terms of time. So give yourself enough time to do it well so you can get a good grade because you know how to do all this. As I said, any questions, just let me know.